All right, so this is how to multiply with binomials. So essentially what we have is just trying to multiply it together. There is the slow way, and then there's a really quick way to do this here. So look at number 1, for example. So it's x plus 3 squared. I'm just going to rewrite it so I have a little bit more space. So x plus 3 squared. I could write it as x plus 3, x plus 3. Right, because same parenthesis, just 2 times, just the same as if I said, oh, what's y squared? I could write it y times y, right? Because y times y is y squared. So I can write it out like this, and then a lot of students have heard, oh, I can FOIL, meaning I can multiply the first term, the outside term, the inside term, and the last term. And you could do that. In this case, it would be x squared plus 3x plus 3x plus 9. Which again you would add 3x plus 3x, which would give us x squared plus 6x plus 9. And we could totally do that. There's nothing wrong with that. But when we get to the pre-calculus level, or again, we're preparing ourselves for calculus, we want to make sure we are being more efficient. Where can we save time? So the way we're going to do that is with this method here. So, whoops. So I'm going to go ahead and write x plus 3 squared. And there's a little trick that we can use to go a little bit more efficiently. So the first term is x, and we're going to square it. So x squared, okay, is x squared. The second term is going to be the first term here, the second term, so times 3, and then we're going to double it. So x times 3 times 2 gives me positive 6x. And then the last term, we just square it. So 3 squared equals 9. So it's x squared plus 6x plus 9. So notice how we got the same answer, right? X squared plus 6x plus 9. But we did it with a fewer amount of steps, and we did it a little bit faster. Didn't have to multiply 4 terms and then combine like terms at the end. Now you might be saying, well, for this problem, it was easier for me to do FOIL than to do this. But when we get more complicated, it's not as simple to do it the longer way. For example, let's do number 7. All right, number 7 here. So it's 3y plus 4 squared. So again, if we were to write it out, 3y plus 4, 3y plus 4, you could totally do that. But again, let's practice our skills that we just learned. And let's do the shortcut. So the first term here, 3y. I'm going to square each piece, which is, again, make sure you pay attention to that. So it's not just 3y squared. It's actually 3 squared y squared, which is 9y squared. Okay? So that's a little tricky part. The middle term, we just multiply those two terms together. So 3y times 4. And then we're going to double it, so multiply it by 2. So 3 times 4 is 12, 12 times 2 is 24, so 24y, it's positive. And then we square the last term, which is 4 squared, which is positive 16. Okay? So the tricky thing here was when you square the first term, it's 3 squared and y squared, not just 3y squared. Okay? Let's do one with a double variable, just to kind of get another example here. So 3p plus 5q squared. Even though it looks a little different, nothing changes about the procedure. We square the first term, so it would be 3 squared p squared, which is 9p squared. Plus, we multiply the first two terms, 3p times 5q, and double it. Let's deal with the numbers first. 3 times 5 is 15. 15 times 2 is 30. And p times q, again, I can't really multiply those together, so we'll just write them next to each other, pq. And then it's 5 squared q squared, which is going to give me 25q squared. All right, so again, it's another method to use, but remember, we're trying to save time here so that we can focus on more difficult processes. Multiplying binomials needs to be something that we need to be really good at, and so this is one of the shortcuts to do it.